So, to find the potential energy for this whole system, the potential energy is defined as the integral of the force, and in this case we're using curvilinear motion, so it should be just the force along this system rather than in both the x and y directions. So I looked at the forces in this, and since we're using curvilinear motion, the forces of tension will cancel out because they're equal and opposite. So you really only have the force of gravity acting. So gravity potential energy is just mgh. And if we consider the zero potential energy to be here, since this is where the height is labeled, and that makes the most sense for this problem, solving for the heights with trig functions, you get, for little h, you get b over tangent theta, and for big H, it's L, which is the length of the string, minus this part, which is b over sine theta. And just simplifying that, you get this for the potential energy. And then to find equilibrium points, you take the derivative of the potential energy, and this is what Mathematica gave me, and set it equal to 0. And just doing some algebra, we find out that the derivative is equal to 0 when little m over big M is equal to cosine theta. So that's an equilibrium point. And just as long as little m is smaller than big M, this is big M, just to make sure that cosine is less than 1. Those are the I guess what's the word I'm looking for? Conditions. Those are the conditions for the masses. And then to test the equilibrium point, you take the second derivative, which is this lovely thing here, and I rearranged some things, and I took out a big M so that I could get this little m over big M term, and I factored things out and multiplied things, and eventually get this GB big M cosecant theta times the cotangent squared theta plus cosecant squared theta, and this will always be positive, and then this part will be positive as long as cosecant theta is positive, and so that would make it a stable equilibrium point. In order for cosecant theta to be positive, then theta has to be between 0 and pi, which makes sense in this problem because hopefully the mass isn't going to go up here. It just makes sense for this problem. And I believe that's it.